I just wanted to make a minor amendment to the title and just prefix it with more functional programming for trading systems. And the main issue is of course, are there any Haskellers or ML people? Yep. Okay. So this is obviously not quite going to be talking about a pure functional programming, but there's some really common elements of functional programming that Erlang, gives us, and decorative style and things like that. So this is a little bit small, but so this is really one developer's journey, going from bloated object-oriented code bases and enterprise architectures. Who here lives in the enterprise world? Yeah, okay. How many of you are Java or have been? Okay. So I don't stand before you as a high priest who has never sinned. I stand before you as a former sinner. So I'm looking for redemption, actually. And I kind of went towards a more maintainable, honest distributed systems kind of work and mindset, and it's actually the mindset that's important. So I just wanted to talk a little bit about what I mean by bloated. So when I was working with Java and C++, even more sin, I'm sorry, I really found that a lot of times when we wanted to build more flexible systems, more pluggable systems, we added a lot of bloat and boilerplate. And it was really, after a while, I kind of wondered, does it really have to be this hard, right? To get that flexibility, to get the ability to abstract over computation and things like that. And so anyway, so that's when I started to become disenfranchised with the Java world. And I just wanted to highlight object-oriented here because I wasn't the kind of 9-to-5 kind of programmer that just forgot about everything. Programming, I read all of these great books on design patterns, the enterprise application patterns and all that sort of stuff. But I was very kind of closed, right, inside of this object-oriented enterprise world in terms of my mindset, until a very happy accident, as it turned out, had me on a team with an ML person and a Haskell person who had fights every single day, actually, between themselves. But and I was the only sane person on the project, except I learned a lot, actually, on this project. And of course, enterprise, here I'm really talking about, the mindset of, we have n-tier, kind of, multiple layers, and, we back up to we're backed by an ACID-compliant database and things like that, and everything, all data is structured, right? And just some fallacies involved in terms of, adding caches in every layer and then having queues and things like that, and just kind of wondering about what's the purpose of making things harder on the back end in terms of data storage, when we're really not presenting that to our users, right? So I'm not here presenting you with kind of a nirvana state, right? But I do think that today I think better, and I'm able to kind of produce more maintainable and honest distributed systems. And notice that the work has an asterisk. I don't have the disclaimer there, but for the most part, it works, right? Not everything is fantastic. But the key here is it's more maintainable, right? What I'm going to hopefully be able to present in terms of programming in the small, the techniques that I'm using and things like that, and honest. So here I just really wanted to talk about, I'm thinking when I start projects or when I start thinking about adding new things, I want to think about the properties of the system and think about it from that perspective, and actually relatively prioritize those properties, because we don't need strong consistency guarantees everywhere. Maybe we actually want to optimize for something else, like high availability or something along those lines. And having the right kind of mindset and not thinking that you can get everything for free is kind of important, and knowing where you take the your trade-offs, right? So this is about me and what I learned specifically from Erlang, right? So, okay, so what is functional programming? I'm just going to go through this pretty quickly, but we've got immutability. In Erlang, we have matching semantics rather than assignment semantics. So, you know, the first time it matches, it retains that value, and it can be used that way, right? But we don't have this notion of assignment where you can keep assigning to a variable. Okay, so we have that in Erlang. And also we have the ability to pass functions as values around in Erlang. This is going to be something that I'll talk a little bit about and show some code. Okay, so referential transparency, we don't have a type system that, you know, tells us, you know, what is okay and what's not, or what could be tainted when we perform it and things like that. But we get a lot from the first two, and if you can inspect the code and you know that it's pure because you've inspected the code, you can reason about things, right? But you know, we don't get some things for free, and it's not enforced. So I'm going to be talking primarily about programming in the small, and this is. So I'll be showing some code examples for various things and comparing and contrasting sort of an object-oriented imperative kind of way of coding with a declarative functional way. So pluggable strategies, like in Java, you know, we have the JDBC libraries where, you know, you can load up your drivers for the different kind of backends that you might be wanting to use and use a consistent API, and the same probably applies in .NET, but I don't know what library that would be. But you know, a lot of object-oriented systems have this kind of thing. And there was an article, actually, that was written in 2011. I later found out. I thought it just was written last week or something like that, but that's just when I found it. And it was about this this gentleman, I don't know who he is, called Bill Woody, and how not to write factorial in Java. And his main point is that our reflex in the Java world, in the imperative object-oriented world, although, well, we'll talk about that later, is that, you know, we add in all this boilerplate to make things flexible and to be able to plug in and plug and play different things, right? Different computational strategies and things like that. He used factorial as an example. That was a pretty lame example, but whatever. You know, he actually says, you know, but here, you know, he develops this whole like number of steps of how he might make this more and more pluggable. And then at the end he says, you know, but my point is it's all crap, every last line of it. And his point is that you rarely need, his point, to be able to plug and play computational strategies. And I slightly disagree with the frequency with which we need that. I think we need it a bit more than very rarely. Things like, as an example, you know, being able to plug and play different value at risk algorithms or encryption algorithms and things like that at runtime, rather than you know, actually inside of the code itself. But I do agree with the idea of limiting the knee-jerk reaction, right, of trying to make everything pluggable, right? But he missed an opportunity, which is, why is it so darn hard in Java to do this, right? So, so let's have a look. I actually purposely didn't include the whole code, but there's one thing here that struck me as I was going through the code. And it was something that I found myself when I went back into the Java world a couple of years ago. And that is, there's a whole bunch of code that has like interfaces that have one method signature. This is like a big telltale sign that you actually want functions, right? And you want to be able to pass them around as values. And just a note that in his implementation, of course, he was trying to make a case against doing this kind of flexible plug and play kind of thing. So maybe he took some less nice approaches to building this in Java. But you know, it's about 40 lines of factory class code and 20 lines of util static stuff. And there was minor overhead in the fact that you had to implement this interface in a class and then define the factorial method here. But that's really nothing, really. Okay, so I don't actually want you to focus on the code itself. Try and blur your vision and look at the left-hand side indentation. Does that look like a healthy program to you? This is a bit of a rule of thumb. It doesn't always apply, but when I look at programs, I first look at the left-hand side indentation, assuming that it's in some kind of readable indentation for the language. And if it looks something like this, I think that there's something very sick with it. And also note that this is just one small part of the factory class, and I actually had to truncate it a little bit. But this is really focused on how we look up the factorial algorithm, and it's really mechanics. It doesn't really have a place in terms of defining factorial at all, but it was somehow necessary. Okay, so I omitted all of the implementation details in Java for the different computational strategies, but here we've just got a module. Well, I missed the module declaration, but we've got like a naive implementation of factorial, and we have two function clauses. This is something that Corey Haynes said that he kind of fell in love with when he was learning Erlang, right? That we have these function clauses that we can branch out our implementation, and you'll see here that if we pass in factorial naive with the argument 0, we're just going to return 1, right? It's a really simple case, but we need that terminal case actually in this case because we're doing recursion. Well, not optimally, but we are doing recursion. So, but in the top, we actually have a very definitional way of defining our program, right? We say when n is greater than 0 and it's an integer, then we use this definition, right? And we separate out the what from the how, right? And this factorial memoized, this is kind of inlining the memoization. Factorial is a boring example, but I figured I might as well compare apples and apples. And I've omitted the function clauses for 2 until 19, but you kind of get the point, right? Factorial is a pure function. Every time you give it the same input, it's going to return the same output, right? So, so this is a very definitional way of writing code. And then we can just use the default implementation, or we can pass in, the algorithm that we want to use to compute factorial with the argument at the bottom. And the way we would, so the first part of this code piece is just extracting, the environment variable, the configuration variable for like the factorial definition, pulling it out, and maybe you're looking up, the atom with the function somewhere, but it's that's another line, right? But then here, the client call is being able to pass my own factorial implementation to this function, and it calculates using that. And note that this is actually more flexible than the Java solution that he sort of proposed, not really, in the blog post. So I really want us to talk a little bit about implementation versus definition, or imperative style versus declarative style, and that is the Java. Java code tends to be written in this, implemented really, right? When you write Java code, you're implementing something in, and it's a very natural style in Java, right? It's the main natural style. In Erlang, we actually try and declare things, right, and define things, and that's the natural style in Erlang. So declarative style makes it simpler, meaning less complex, actually, the code that you have to maintain. And that makes it easier to test. and maintain the test suite itself, right? And it has a clearer interface. Now, this is, a bit of a, this is factorial. This is a little bit boring. But from experience, I can say that this is actually true, right? Out of the object-oriented developers here, how many of you do testing? Either test first or, Okay, great. So when you first started to learn to write tests and things like that, did you ever confuse implementation details with in assertions and things like that? Well, when you're writing things in a more decorative style, you don't really have that kind of issue, really, right? Because you're not focused on the implementation details, first of all. You're looking at the interface, right, and understanding the properties of the interface itself, like invariants and things like that. I was there too. Again, I'm a reforming sinner myself. Also, writing code in a declarative style makes it less likely to miss boundary conditions, right? So we, in Erlang, we had the ability to put guards in our function clauses. That exists in a couple of other functional languages. It's not exclusive, perhaps, to functional languages, but it does seem to appear in a few functional languages. And, as a result, the code reads more clearly, and we're probably less likely to miss those kinds of those conditions, those boundary conditions. And being able to pass functions as values removes the whole interface and factory kind of boilerplate, right? And all of that how nonsense. It just kind of goes away. So we're left with the ways to compute factorial. And then also looking up, which one at runtime I should be using, right? Whether it's from a configuration file or the command line arguments or whatever, right? So that's what we're left with in the declarative style. Okay. So just to recap, so we can do less. We can do more with less. And by less, I mean we have less complexity, but more of our code is actually related to the application logic. Actually, I think I'm confusing 2 points, but we're also separating concerns, right? We've got the way we execute factorial is going to be kind of decoupled, separated from what the application logic looks like and how it's defined. And maintainability, when more of your code is actually focused on the application logic itself, you don't have to read through a lot of implementation details of, we needed to do this at one point because we were running on these kinds of servers or, whatever, right? We just have a much clearer focus on the application logic itself. So, functions. I love functions. So there's a couple of different types of functions. There's first-order functions where we're just abstracting over data, right? We don't accept as arguments or we don't return functions. These are, we're familiar with these things, right? There's something like factorial, right, for example, is just a first-order function. They're sort of interesting, but, abstracting over data only gets you so far. There's higher-order functions that can accept functions as arguments and or return functions as return values. And then a subcomponent of that are combinators. And this is where you can either use function application or other combinators to derive your return value. And that's just a subset of higher-order functions. So let's just have a quick look. This is a module called either. The Haskell people will understand the concept of either, but in Erlang we have kind of a set of wrapped values, I'll call them, just basically tuples of various patterns that are really common in return values, actually, from the OTP APIs and also from standard libraries. And sometimes you might get a list of these either values somehow, and you want to be able to extract just the errors really easily, or the success values from that list, or partition them, right? You might want both, but you want them partitioned so that you can deal with the errors separately from the successes, or maybe in parallel. And so the errors function is really just, this is incomplete, by the way, because I actually pattern match later on more patterns, but for errors, but that's kind of more of a implement. That's just in the detail. But so we're just gathering all of the errors together, and the errors functions, success is the same thing, and partition, we're returning a tuple, right, of the errors and the successes. And here we have a really simple function that takes two functions, one that can be applied to the errors, to an error value, one that can be applied to a success value, and of course any perhaps a value that we want to apply it to. But we don't want to know the details. We don't need to write out these case statements, these case expressions all the time and all the different parts of the code. We're just extracting this into this function, and then we get the desired result at the end. And we can do this again, except we're not taking a value as input, an either value as input. We're just returning a function that can later on be applied to an either value later on. And you may be passing that to decouple things to another part of the system that will need to deal with some kind of either function, either value. Okay, so what's a use case look like? So if there is a module in Erlang called CSV parser, this is not necessarily modeled after it. I was just messing around, but say we've got a CSV parser, we want to be able to parse a CSV file, and we get back a list of either values, and that determines whether or not it parsed each of the lines successfully or not. And if you have traders that are uploading really large CSV files or whatever, you don't necessarily want to just return back to them with the very first error, because if it happens at 11,063, line 11,063, but then there's like 10 more, you don't want to have them upload that CSV file every single time just to get to the next error. You want them to be able to fix it and then resubmit so that everything goes through the second time. And we're using the partition function to get back a tuple of the errors and successes. And what we could do here then is send back the message for, these are the lines that there was a parse error at. But here's a partial view of what it might look like if we applied some kind of transformation on your CSV file, your CSV file, whatever your system is really trying to do for the trader or the analyst or whatever. Further down, we have something like DB store, right? We have some input. Maybe we've sanitized this input from a web form or something like that. And the DB module that we have someone else has written returns an either value. And here we have the either value, so we can just apply it to, we can just pass it into the either value. And we've got this render error and render object, and maybe you're returning JSON in a REST API or something like that, and there's certain formats. Maybe you return certain links or something like that inside of your JSON object literal. If it's an object, some extra metadata or something like that, versus an error which you may want to map to some kind of error codes or something that are maintained in your documentation or something. So you want to be able to just pass in, this is the function to apply if it's an error, this is the function to apply to if it's an object, and you declutter your code. Right? This is a really simple example, but I thought I'd just use it. So hopefully people can follow it. Higher order functions are mildly useful. They are everywhere, but this there's also kind of a common pattern. So here, we've got lists, functions, and, for everything from filter at the bottom to, determining whether or not a predicate holds for all of the values or just at least one of the values or something like that. And there's a whole bunch of these functions in the lists module that actually utilize one underlying function, a fold function, and there's a recurring pattern there. And you can even abstract upon that. And when you get into that kind of mindset, it becomes very powerful, and you can express things much more concisely. So the higher order functions, they yield more maintainable code, and it happens to be more reusable most of the time. And I think that's kind of, for me, the important thing, that you focus on maintainability rather than reuse. You can take this too far, right? And, maybe there's some libraries in Haskell that I would say that, right? When you get like 6 type variables, it becomes questionable in my view. But and there's one important combinator in functional programming, which is compose. And it looks something like this. I think a lot of people may be familiar with this notion, but you have 2 functions. The output of one is fed into the other. And we can have a look at a very quick example, kind of trivial example, but it hopefully gives the point across to those uninitiated. But, we have a double function and then an increment function. We can increment first and then double. That yields one result, or we can increment double first and then increment. And the key here is this is, again, decoupling your code. You've got different definitions and also reuse, right? So we've reused these double and increment functions. They could be anything, right? They could be calculating, some kind of risk or something like that on a specific kind of asset class or whatever, and then filtering it through to kind of cleaning up data or sort of error or, something. Okay, so I want to talk a little bit about algebraic properties, and if you leave now, it will be your loss, maybe. So the example I'm going to go through is testing list sort, and we're going to first go through a case-based testing approach, and then we'll look at a property-based testing approach. So we'll start off with the base cases as the empty list, right? I think we can all agree that if we sort an empty list, we should get back an empty list. If we sort a single element list, we should get back the same single element list. There's really nothing to sort. Okay, so now we've defined an unsorted list, and we've manually calculated the sorted list somewhere, right? The actual value isn't all that interesting, other than it has to be a multi-element list. We've got the single value, right, of the unsorted and the sorted. And so if we sort an unsorted list, it should be the same. It should equal the sorted list. And again, we want to make sure that the sorted list sorted is the same as the sorted list, right? This is perhaps a little pedantic or something, but whoops. And of course, this still works on any kind of sorting algorithm, because the semantics of sorting are pretty clear, right? So we could swap in and out different sorting algorithms underneath the covers. And so here we're getting the head of the sorted list, and that should equal, so that should equal the minimum of the unsorted list, right? And we'll do the same, except for the last element of the sorted list should be the maximum. Okay, so let the fun begin. So you may not realize it, but the sort operation is actually idempotent. So that means if you apply sort to a sorted list, it should return the sorted list, right? The expected sorted list. And this is using a library called, it's actually the free version of quick check in Erlang. And what we're saying here is, for all L, which happens to be a list of ints, if we do lists sort on that list, then it must equal list sort of the sorted list, of the same underlying list, right? The L list. And another property is that the length of the input list and the sorted list should be the same. And again, we're doing, the last element of the list should equal the maximum of the unsorted list. And the same with the head and the minimum of the original list. Oh no, what happened here? I've actually got this really ugly error message. It's because one of my assumptions was wrong, actually, in the previous slide. Let's have a look. So here we're trying to construct any list of ints in the bottom two. But actually, if we try and get the last element of an empty list, it just dies, right? And that's expected, right? The same as if we try and get the head of an empty list, again, it dies, and that's expected, right? So thus this. And you can't see it very well, but at the bottom it actually shows the case that it failed on was this empty list right here. And it failed after one test because it generated the empty list as the first value. Okay, so basically, right? I'm not very good at this. So let's think about this, right? So basically, we want to make sure that it's a non-empty list that's generated for these two cases. The other cases, it can be an empty list, right? Because we should be able to handle an empty list in the other two properties. So now, yay, right? We're doing well, right? So here it randomly generated 100 inputs using the generator non-empty list of ints, and now it after those 100 inputs, it passed the properties, right? Both of those properties. Now that doesn't mean that it absolutely works, right? This is not a proof by any means, but this is something. Oops. But the key thing to think about here is we're not limited by our own imagination in terms of the test cases, right? We just tell it what the specification is, and then it can produce values that adhere to that specification. And then sometimes we'll find out that our specification was crap, like the original specification, and that's actually good, right? We get immediate feedback. And you may not find the right feedback. It may be an obscure part of your specification that is just incorrect. The example that I gave was a very obvious one. But it could be very obscure, and you may have to run this several times before you find a case where it doesn't actually, where it doesn't hold this property. And then you'll have to investigate whether or not it's the specification that's the problem, or your implementation itself, right? Okay. So to summarize, we've really looked at just programming on the small right now. But hopefully this kind of gives you an idea of how functional programming and declarative programming, even in something like Erlang, which isn't a pure functional language, really has a lot of power. And compared to imperative object-oriented kind of languages, where it's imperative is a natural kind of form, there are a lot of programming and the small benefits from maintainability, kind of making it more focused on the application logic, and being able to abstract over computation much more naturally. There's just a couple of other things that I wanted to mention, and that is some bigger ideas, right? Not just programming in the small techniques like this. We have things like Garrett mentioned and Mahesh, isolation, right? Isolation is a big deal. And so what do we get from this, right? We are separating out some kind of, maybe not error handling, maybe that's the wrong word for it, but how do we recover, right? Our recovery logic from the success cases. And we don't want to focus on error handling because that can kind of really bog you down in details that are really not pertinent to your application, right? So has anyone here stuffed too much context into an object just so that it knew how to handle an error, right? Well, that's kind of a big smell, right? I've done that too, and the best way is to let it crash, right? And then you have some kind of recovery strategy and policy in place, handled separately, actually. You define that policy separately from the actual application logic that runs, that may have crashed in the first place. But I think it was Joe Armstrong actually said, he doesn't want to perform heart surgery on himself. He wants a surgeon to do it, and that's kind of the same thing here, right? We've got a supervisor that's going to be the surgeon, and it's going to do the surgery on a patient, right? And the surgeon and the patient should never be the same, right? The same person. And there's a good reason for that. I think we can all appreciate that. So concurrency is another big deal, right? The basic, one of the basic principles of declarative style and functional programming is to separate out concerns, and that lends kind of naturally to concurrency, right? To being able to build more concurrent systems. We have these little pieces of sequential code that talk to each other, and so the sequential part is much easier to think about and reason about and write in the first place. And but then you have this non-determinism because they're all passing messages at different times. The sequence of which messages, how they come into certain processes and stuff like that, you may not know, right? And you may not be able to reproduce necessarily, but the actual logic itself should be small and self-contained, and it's sequential itself, right? The fact that we are able to pass messages between these processes, that's kind of the mechanics that the Erlang runtime system handles for us, right? And so we're separating application concerns in this case, right? And events in finance, especially, I think events are just everywhere. It's like a really obvious abstraction to build event processing, event-driven architectures in finance. I think that's becoming more and more the norm. And immutable data, right? An event is immutable. You create an event and you store it and it's just there, right? You don't have to update it. It happened, right? You can't undo an event. An event happened. If I have a car crash, I can't just, until I invent time travel machine, I can't go back and undo it, right? That happened. That's a fact, right? And so they're everywhere. They're not just in finance, but I think they're especially obvious in finance, right? So we can do things much more naturally in a language like Erlang, with event stream processing and complex event processing. And in fact, what Corey mentioned right before me, the whole system that he built of representing sort of the brain as he understands it is, and I have no idea, so I'm not criticizing him, it's actually very similar to event stream processing and complex event processing itself, right? The way that you would build something like that. And it's a very natural style to be building systems in Erlang. So interfacing, you can actually interface with different languages within, when running in Erlang, but, C, C++, Java, Scala, but you can actually build all kinds of interfaces, but that's really, think about what you're trying to do, right? Don't use a C implementation for something without data, right? Have data to back it up. Make sure that it's warranted, because if you're using it as, in certain ways in the Erlang world, then it could crash your system, right? Because you're introducing something that doesn't have the same semantics as Erlang, and it could just crash like a lot, and that would be bad, right? So make sure that you contain this part of the C or C++ or the Java or whatever, right? So thanks for your time. So are there any questions? Yeah.
XSLT, I found myself writing a lot of zombie code. It looked good, but it was dead. It would never get hit because the patterns would never match.
Oh, yeah.
And it seems like I might do the same thing in Erlang.
Yeah, you could. There are actually some good... Oh, yes. So the question was, in XSLT, the gentleman that asked the question found that there was a lot of zombie code patterns that never actually matched. So it seems like the same thing could happen in Erlang. That's absolutely true. There's actually a lot of tooling around that. There's tools called Dialyzer and things like that, where you can find out, if anything is actually hitting that thing. I mean, if you're releasing it as as a OTP application for others to use, maybe you don't necessarily know what's being used outside, but if you're using it inside of, you have the context of your application calling into your part of the system, then you can actually tell what's actually being used and what's not. And it'll kind of warn about stuff like that. So there is actually tooling around that to kind of inform you of those kinds of things. Anyone else? Well, thank you very much.